All right. So we did like uh, Archimedes principle and we proved it. So now let's go forward. So there are basically three conditions that we need to know. Okay. First condition is that there's an object that has a weight downwards and then it has upthrust upwards like this. In a case where the weight and the upthrust are equal, it means the object will float. Right. I just wanted to tell you by W I would mean weight, by U I mean upthrust, by D I mean drag, right? Now then in a case where the weight is larger than upthrust, so the object will go down like this, and the velocity is down, which means the drag force will also be there, like against the velocity. And in this condition, the object will sink. All right. Now, then in a case where weight is down and this time the upthrust is larger, then the object basically starts to rise, and because the velocity is up, the drag force will be down. In this case, you should remember that the object will rise. All right, is it clear? Any questions? Please let me know. Right. So generally in the sinking, you should remember upthrust is basically the in the sinking, the weight is the largest force, so it will be equal to when it's moving at constant velocity, upthrust plus the drag. And in this one, the upthrust will be equal to weight plus drag, because then it will balance the whole thing and it will start to move at constant velocity. That's the terminal velocity, right? That we did in kinematics as well. Now, if you guys have any questions, please let me know. Is it clear? Aman, Javeria, Aisha, Raman?
Yes, sir. Yes, sir.
Okay. Now, so then there's basically a way of finding the combined density So basically, you need, suppose um, there are two objects that you combined. Let me just combine with different colors. One of them has a density rho, the other one has density 2 rho, right, like that. So what you guys are going to do is, suppose this has a mass m and this has a mass m as well, right? So I just want to tell you the correct way of solving or finding the combined density is that first of all you're going to find the total mass, which is going to be m1 plus m2, and then you're going to find the total volume, which will be v1 plus v2, and then the combined density can be found out by dividing the total mass over total volume. So this is the correct way. The wrong way, which most of the people do, right, that they take combined density they find m1 and divide by v1 and then add with m2 and v2. So you're not supposed to do that, because basically this is simply like you're adding the both densities together, which cannot happen. And if you see both of these functions that you see here and here, one is m1 plus m2 or v1 or v2, one is m1 v1 plus m2 v2. That's basically a completely different math function, and you don't want to do that. Am I clear here? All right, now what I want you guys to do is I just want you to do the same question here, and I want to say that find the combined density in terms of rho of above figure. So you know that it has, one has a density rho, one has 2 rho, and mass m and m, and I want you to find the combined density in terms of rho. Can you guys do it, please? Hurry up, please. I think Ramin can. I think. Unless she's sleeping.
I was sleeping, but how can I?
Yes. Wake up, Ramin. Wake up.
So is it M1 plus M2 with 3P?
M1 or M2, but M has a value, Raman. It's just M. M1 is also M, M2 is also M. Alright? That's not correct then.
Yes. So it's 2M.
2M, but there's no M. You're supposed to only write it in terms of row, not M.
Oh, okay, okay.
Sir, is it 4 by 3 row?
4 by 3? Yeah, that's correct. Very good. Alright. Now, nobody could do it. How sad. Yeah. How sad. Now, let's check it out then.
Sir, I said 4 by 3.
Oh, yeah, you said. Okay. Okay, Javeri has done it. Aman and Raman and Aisha. What happened to you people?
Sir, 4 by 3P.
Yes, that's correct. Okay, Aman, could you do it or no?
Same answer, sir.
Very good, very good. So density would be total mass over the volume. Basically, volume of one will be mass over density. Volume 2 will be mass over density. So I believe you guys have done m over rho plus m over 2 rho, and then if you take the LCM, it will be 2m over 2m plus m divided by 2 rho. M basically cancels out. So 2m plus that will be 3. M will cancel out, so it will be 2m over 3m over 2 rho, which basically comes out to be equal to 4 over 3 rho. That's the combined density. That's very good. Excellent job, everybody. Now let's move forward. Now the next thing we're going to do is basically the atmospheric pressure. The atmospheric pressure basically is taken out through a mercury barometer. A mercury barometer basically has a shape like this, and basically what you have is you have mercury inside and there is vacuum, and within that, when you basically add vacuum, the air pressurizes the mercury to fill it up, so the mercury basically rises like this. What you guys need to understand is that suppose they have given you this top point till this base. This is the height that is required, and this height, or you could say depth, is the one that you need to see. So let's suppose if this is 76 centimeter, right? So you need to understand that the pressure, so I'm going to take 2 points. I'm going to say this is suppose PA and this is PB. So at PA, I want to tell you the pressure is 0 because there is nothing above it, but at PB the pressure can be taken out by taking 76 centimeter of mercury. Now when you say 76 centimeter mercury, what we really mean is that it means that if I apply the formula, which is rho GH, I just need the density of the mercury, which is basically 13,600. 9.81 is the acceleration due to gravity, and the depth is 76, that I can change to 0.76 meters. And if I try to find this is gonna be, I think,
What is 13,600?
that's the density of mercury. Let me write it.
Okay.
Density of mercury is 13,600 kg per meter cube. So, well, you don't need to. Well, you need to remember this. Like they can ask you in the estimation, so you should know. So when you find this, so it will be 13,600 times 9.81 times 0.76. So that comes out to be 1.01 times 10 raised to 5 pascals, which is a value that is a standard value, and we call this as 1 at ATM, which is 1 atmosphere, and that's the pressure at sea level. This is the amount of pressure at sea level. Now I just want to ask you a question. Let's suppose you're like sitting in Karachi, and then you're sitting in Dubai, and then you're sitting in Sydney. Would the pressure at sea level change? Anyone? Would it change? Going from a sea at a different city. Yes, Aisha, what do you say about it?
No.
No, because sea level remains the same. That's good. Okay, so the sea level will remain the same. That's why it's a fixed value, right? Now, if you go to any other place, right? So basically,
But
what?
sir, doesn't the depth of each sea vary, and then pressure should also vary?
Who said going inside the sea? You just
No,
at
but
the sea.
for okay, fine.
Do you understand? So the atmosphere above every city which is at the sea level is the same. So we're talking about the depth of the atmosphere. We're not talking about the depth of the sea. Understood?
Yes. Okay.
Okay.
Yes.
Now keeping that in mind, we'll do some examples, and now we'll see how to deal with multiple layers of pressure, right? And that's what basically you are confused about, and I want to explain it to you. So suppose that we have a container which is open from the top, and then it has different layers in it. So there is a layer of material that has a density of 1200 kg per meter cube, and then there is another layer on top of it which has a density of 800 kg per meter cube. And because it is open from the top, it means that the atmospheric pressure will also be acting. So let's call this P naught, and that pressure is 1 atmosphere. We already know what is the value from previously, right? So suppose if somebody wants to go swimming, and they like go into like the really at the bottom, right? And they have given the heights as well. So they say, okay, this height is 5 centimeter, and this height is 7 centimeter, and the question is that find the pressure acting on the person at the bottom, right? Now just remember something very, very important, that the atmosphere is acting, a pressure on top of the green liquid, and then the atmosphere and the green liquid are combined, and they are basically putting a combined pressure on the pink liquid, and the pink liquid and the green liquid and the atmospheric pressure is putting the pressure on that person at the bottom. Just keep that in mind. Which means that basically the total pressure above this person would be, say this is P2, this is P1, P1 plus P2 and the atmospheric pressure. So you have to basically look at that way. So then we can write that this P1 is 1200 times 9.81, because we're doing rho gh, times, we're going to take only the depth of the liquid we're looking at, which is 7 centimeter, that comes up to be 0.07 centimeter, then plus the other liquid on the top, which has 800 density, 9.81 as gravity, and then the depth is 0.05, so you're only going to take the depth of that particular liquid, plus the atmospheric pressure, which is 1.01 times 10 raised to power 5. So when you add all of this, it should come out to be 1.015 times 10 raised to 5 pascals. Is it clear, everybody? So the point is that if you want to find pressure at any single point, you need to take all the pressures above it and then add them together, okay? If you have any questions, please let me know. Okay, now then go to the next example, and then we'll do a question which I believe you guys will be able to do easily. Now it says at a depth of 20 centimeter in a liquid of density 1800 kg per meter cube, the pressure due to the liquid is P. Now they say another liquid has a density of 1200 kg per meter cube. So what is the pressure due to this liquid at a depth of 60 centimeter, right? Now what they're saying is that the pressure 1 is P, you got to find the pressure 2 if the gravitational field strength is just G for both of them, right? It's G and G. H1 is 20 centimeter, this is also G, this is also G. H2 is 60 centimeter. Density 1, wait a second please. Okay, so density 1 is 1800 and density 2 is 1200, so we want to find this. Now, in these sort of questions which basically require a ratio, always remember that when you write the equation, which is pressure equals to rho gh, check which is the common quantity. So in this one, g is the common quantity. So what you're going to do is you're going to make g the subject. So for the first one, if I write g equals to pressure over rho and h, and then you can basically combine that for the liquid 1 and liquid 2, g is equal to g, hence I can write P1 over rho 1 H1 equals to P2 over rho 2 H2, like that. It's simple ratio. Now this is P, this is 1800, this is 20. You don't even need to, because in the ratio you don't need to change the units because they're going to cancel out ultimately. This is pressure 2 that I want, this is 1200, and that's 60. Now to find P2, you multiply this, so it will be 1200 times 60 times P over 1800 times 20, and if you do that, it is going to be you're going to end up with just 2P. So the pressure 2 will be twice as much as pressure 1. Any questions now? Okay. So now in 10 minutes when the meeting ends, I would like you guys to rejoin. Now let's go forward. So now it says a borehole of, and that's the question you guys need to do. Okay. Not an example anymore, because I believe you guys are now, you understand everything. Question: a borehole of depth 2000 meter contains both oil and water as shown. The pressure at the bottom is 17.5 megapascals. Then says the density of oil is 830 kg per meter cube, and density of water is 1000 kg per meter cube. Says what is the depth x of the oil? That's the question. Okay, so the drawing is also given. I'm just creating it. So that would be this is the oil, and that's the water. And there is a atmospheric pressure acting, and and they have also given the value of atmospheric pressure, which is 1.01 times 10 raised to 5 pascals. Okay. Now they have said that this depth is x that we need to find, and the total depth here is 2000 meters. Now try this question, please.
Then have they given the G value, or we have to use the standard value?
You have to use value G 9.81. That's the same. Okay. If you guys manage to do this, I will let you go. That's the deal, Ramin. If it's wrong, then you have to study till 6 p.m. Alright?
What?
Yeah. Alright, go on, please. Hello. हेलो हाँ वालेकुम सलाम, क्या हाल है यार? मैना की क्या टाइमिंग है बिजनेस के? एडवांस मैना 5:30 p.m. Monday, Tuesday, Wednesday business के, right? Okay, alright. Alright, you guys done? Okay, you guys done?
Sir, England was 60.
Sorry?
Sir, 1260.
1260. Yes, 1300 meters. That's correct. Very good, very good, very good. So, about Ramin and Aman, what about you? You guys could do it? So, basically, what you guys need to do is you need to add all the layers till the bottom, which is basically atmosphere first, then oil, then water. Because we don't have this depth of water, so we got to find this depth is going to be 2000 minus x, and then you're going to put it down. Say okay, 17.5 times 10 raised to power 6 is the megapascal. 1.01 times 10 raised to 5. For oil it is going to be 830 times 9.81 times x, that's the depth, plus for water it's going to be 1000 times 9.81 times 2000 minus x. When you solve this, you should end up getting approximately 1300 meters. Is it clear, everybody?
Yes, sir.
All right. Okay.
Sir, can we?
Yes, that's the end of the class then. All right. So I will see you in the next class. Have a nice day. Bye.